Question number 16. Define part A. Define the term specific latent heat of fusion. So, specific latent heat of fusion is defined as quantity of heat. Quantity of heat required to change a unit mass of material from solid state to liquid state without change in temperature. Change in, this is G, in temperature. So that is how you define specific latent heat of fusion. Question number 16b. Ice of mass 5 grams at a temperature of minus 10 degrees centigrade is immersed into 10.5 grams of hot water at 100 degrees centigrade in a container of negligible heat capacity. All the ice melts and the final temperature of the mixture is 40 degrees centigrade. Assuming there are no heat losses to the surrounding and taking the specific latent heat of fusion for ice as LF, we have a specific heat capacity of water 4,200. For ice it is 2,100. Determine, that is joules per kilogram Kelvin scale. So determine the heat loss by the hot water. So heat loss by the water, we can say heat loss by water, we say it is the mass of water you multiply by the specific heat capacity of water, and you multiply by change in temperature. So this is equals to the mass was 10.5 grams. So if you convert to kilograms, it is 0. Because we are working with kilograms here, 0.0105. You multiply by specific heat capacity of water, which is 4,200, and you multiply by change of temperature, which is 100 minus the final temperature was 40. So when you compute that, you'll be able to get 2,646 joules. Roman number 2, you determine the heat gained by ice from minus 10 to 0. So heat gained by ice from minus 10 to 0, we use the same formula. We say it is mass of ice. You multiply by heat capacity of ice, and you multiply by change of temperature. You can say theta or temperature, is just use that. So this is equals to the mass of ice was 5 grams. When you convert to kilograms, because of the heat capacity, you get 0.05. You multiply by 2,100 heat capacity of ice, and change of temperature is from you say 0 minus 10, that will give you 10. And now it means that heat gained by ice was You compute that, you get 105 joules. So that is the heat gained by ice from minus 10 degrees centigrade to 0 degrees centigrade. So let's go to the next part of this question. So part 3, heat required to melt the ice in terms of LF, where we are told LF is a specific latent heat of fusion for ice. So we say quantity of heat required is equal to mass multiplied by the latent heat of fusion of ice, which is equal to the mass of ice is 0. In terms of kilogram, it is 0.05. You multiply by LF. So that is in terms of LF. Then part 4, heat gained by the melted ice. So heat gained by the melted ice is equal to the mass of heat, the mass of ice, you multiply by heat capacity of ice, and you multiply by the change in temperature, or this is let's use change of temperature. So this is equals to 0. You to be able to get 0.005. You multiply by the specific heat capacity is 2100. That is for that's for ice, but for because already ice has been melted, so it is 4200, and you multiply. Now the temperature changed from 0, that is the melting point, to 40, so you multiply by 40. So when you do that, you'll be able to get 840 joules. So that is the heat gained by the melted ice. Let's go to part 5 of this question. Part 5 of question number 16b, specific latent heat of fusion of ice. So we can say here that the heat lost by hot water is equals to heat gained by the ice. So heat lost by hot water is equals to heat gained by ice. Heat gained by ice, and this means from that is from minus 10 degrees centigrade to 0. Then you add that is the melting ice. You add to melted ice up to 40. degrees centigrade. So this means that we had calculated heat lost by water is 2646 joules. So it is equals to heat gained by ice to melt ice, and that is we found it is 105 joules plus heat of melting, that is of melting ice, which is 0.5, that is 0.005, the latent heat of fusion of ice, which is LF, and you add heat gained by melting ice from 0 to the melted ice from 0 to 40 degrees. These are 840 joules. So if you do that, you can use your calculator. You can take 105, 845 to this side. So you can say LF is equals to 2646. You minus 105, you minus 840, and you divide by 0.005, and that will give you 340,200 joules. So that is the heat lost by the hot water gained by the melted ice. So that's how you work out that question, and you should be able to get full mark. In this section you get 3 marks.